So this toolkit is working with distributive property. Students, you've seen this before in previous years, but doing a review on it and what distributive property means, I'm going to show you a couple different strategies on how to find the answers here. First one is 3, and then it's got immediate parentheses, 4 plus x. And so we're thinking about if there's this 3 and there's no operation here, that's indicating that it's multiplication. So you can assume that anytime that you see a number and then you see these parentheses, it's saying I've got 3 groups of 4 plus x. So I'm going to draw a picture of that. And I'm going to represent, let's see, got this pretty looking blue here. I'm going to represent this 4 in this little blue color, and then I've got my x that I'm going to represent in red here. And so what this is saying is I've got 3 groups of 4 plus an x. So I've got a 4 plus x, I've got another 4 plus an x, and I've got another 4 plus an x. And what that might look like on a picture is I've got 4 dots, I've got another 4, these might be pennies, 4 more, and then another 4. And then I've got this x, and we might draw the x like it's a bag of unknown money. We don't know how much money is in there. Here's another one. The x is just a placeholder for something that we currently don't know the value of. So we're going to say it's a bag of money, and then I've got all these little pennies over here, these coins. I've got how many groups of those? 3 of them. There's my second group, and there's my third group, just like I have here. If I were to add up this column, I'd end up with 4, 8, 12, because it was 3 groups of 4, plus I've got an x, plus an x, plus an x is 3x. Okay, that's going to be our answer there. But we're going to look here. How many total pennies? So if we drew them out like this, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I still have 12 pennies, and I've got these 3 bags of unknowns. So my unknowns are going to label as x. So I've got 3 bags of unknowns. Same thing. You can color out your parts there. Now what we cannot do is combine our x's with our non-x's, because go back to the picture. If this is going to be our blue pennies, and this is a bag of unknown, then I can't say that I have 12 plus 3 and say 15x, because I don't have 15 unknowns. I've got 3 unknowns, 3 bags of things that I don't know what's inside, and then I have 12 pennies over here. Okay? We're also going to, so that's one strategy. Here's another one, drawing a picture. The next strategy we're going to use is the area model. So what this is saying is, I'm going to say 3. I'm going to cut this in half because I have 4 here, and then I've got plus x here. So the stuff on the inside the parentheses, is going to go here at the top, and then I'm going to multiply all that by 3. And so this is going to become 3 times 4 to be 12, and 3 times x to become plus 3x. And so again, we have 12 plus 3x as our final answer. We cannot simplify that. And the last one we're going to do is just using arrows. This is saying I've got 3 times 4, 3 times 4, and that's going to be 12. And 3 times x, and that's going to be plus 3x. And again, there's our final answer. I just showed you 1, 2, 3, 4 different strategies for the same exact problem. They all mean the same thing. And in all of them, we cannot combine our x's with the 12 because the x is standing for something that we don't know right now. And the 12 is just clearly the 12 pennies if we were referring back to that picture. Okay, moving on, looking at number 2. This time I'm distributing in the negative sign. I've got negative 5 times x. So I'm going to use just 2 models here, and I'm going to do the area model, and I'm also going to just distribute the negative 5 in. I've got negative 5 here, and I've got an x plus 2. Negative 5 times x is negative 5x. Negative 5 times positive 2 is negative 10. My answer here is negative 5x minus 10. I cannot combine those because those are separate terms. Or I can just do it straight with the arrows. I like to circle it anytime I see that negative sign or that subtraction sign. Negative 5 times x is negative 5x. Look at negative 5 times, I like to circle this to include that sign, negative 5 times positive 2 gives me negative 10. In either case, our answer is the same. Okay? Number 3. I'm showing you one with the multiplication on the opposite side. Does that make any difference in our outcome? The answer is no. I'm also showing you one where we're no longer using x, we're using f, because we can really label anything with any letter. It all means the same thing. Okay? So first, using the area model, and I've got 2, and then I've got f minus 6. It does not matter that I moved the 2 over here. I could have wrote it over here and still multiplied it in this way. Or I could put it this way. It's going to mean the same thing. 2 times f is still 2f. 2 times negative 6 is going to give me minus 12. Do you see how I brought that subtraction sign and I put it right next to that 6 there? My final answer here is going to be 2f minus 12. I can also just use the arrows like I've done before and say 2 times f is going to be 2f. And 2 times negative 6 is going to be minus 12 as our final answer. Either one of those work. They are the same thing. And last, number 4, looking at distributing in this negative, we're using n instead of x, and we have a subtraction sign. I'm going to circle the negative 4. Negative 4 times n is negative 4n. Negative 4 times negative 5 is a negative times a negative, and that's going to give us a positive 20. This is going to be a common mistake that people will make, is they won't be distributing in that negative, and they might do 4 times 5 and make that 20 and make a subtraction sign there because they see that subtraction sign. Let's use the area model so you can make sense of how that just worked with that addition sign there. So we've got n minus 5, and then we've got a negative 4 over here. Negative 4 times n is negative 4n. Negative 4 times negative 5 gives me positive 20. So do you see how this is the same as that?